Hi, and welcome to TEMEKO. In this video, we will discuss the conditions that need to be met for the equilibrium of a rigid body, and how you can solve different problems related to the equilibrium in coplanar cases. Let's get started. So what are the conditions in which equilibrium of a rigid body can be attained? Well, think of a three-dimensional rigid body which is either moving with a constant speed or is at rest. As you know, the body consists of multiple particles, but we are going to observe only one of its particles. Let's call this particle the ith particle of the body, which is subjected to two types of forces. One of these forces is the resultant external force Fi, which can be caused, for example, by the gravitational force and the contact force. Another type of force is the resultant internal force Fi, which is caused by the interaction between the ith particle and its neighboring particles. Now we can say that the particle is in equilibrium when the combined effects of these forces are zero, as stated in Newton's first law. This leads to the following equation: Fi plus Fi equals 0. If we would also apply this equation to the other particles of the body, then we would obtain summation of Fi plus summation of Fi equals 0. Before we continue, I would like you to think for a few seconds about the relevancy of the sum of the internal forces summation of Fi. Do we actually need it in the equation of equilibrium? No, we do not. But why is that? Well, if you recall Newton's third law, it states that if one particle is subjected to an external force by the other particles, then this particle will create the counterforce which has the same magnitude but in the opposite direction. Therefore, only the sum of the external forces will remain in our equilibrium equation of the rigid body, which will be simplified as follows. Summation of F equals 0. Similar to the equilibrium of a particle, to achieve the equilibrium in a rigid body in a coplanar two-dimensional case, both the x and y components must be 0. Therefore, we get the following equation set: summation of fx equals 0 and summation of fy equals 0. Another condition that must also be fulfilled to maintain the equilibrium of a rigid body is that the resultant moment acting on the ith particle about any arbitrary point O must be equal to 0. For this condition, we get the following equation: summation of MO equals summation Ri cross Fi, which equals to 0. One thing that you should note is that in practice, all bodies are three-dimensional, which often results in us solving the equilibrium of a rigid body by using several equations. Because an unconstrained body can have 6 degrees of freedom, we need to use 6 different equations for solving the equilibrium of the body. 3 of them are related to forces which can be written as scalar equations as follows: summation of fx equals 0, summation of fy equals 0, summation of fz equals 0. The other 3 equations are then related to the moments, which are summation of mx equals 0, summation of my equals 0, summation of mz equals 0. Although in practice the bodies are three-dimensional, in this course we are going to mostly deal with equilibrium problems in coplanar cases. Therefore, the problems will be more simplified and easier to solve in this course. However, you will most likely encounter three-dimensional equilibrium problems in further courses, which is the reason why we had to touch on this topic a little bit. Let us now move on to the second topic of this video, which is how to solve rigid body equilibrium problems in coplanar cases. As usual, the first thing you should do is draw the free body diagram of the system observed, which in this case is the rigid body. In this step, you will establish the positive directions of the x and y axis, and you will show all the forces and couple moments acting on the body with their magnitudes. For unknown forces and moments, you can use the following labels: ax, ay, ma, etc. Also indicate the dimensions of the body on the diagram. After you have drawn the free body diagram of the body, you can start to apply the equations of equilibrium which we have presented for the rigid body. One thing which you should take into consideration when applying the equations is that the order in which you solve the equations may have an effect on the simplicity of solving the problem. So before applying the equations, first consider what is the best approach to solve the problem. Another relevant consideration is that if you get a negative magnitude value for an unknown loading or support reaction, then its direction was labeled incorrectly on the free body diagram and should be reversed. Hopefully, after watching this video, you know in which conditions the equilibrium of a rigid body can be obtained, and you also know how to solve different types of problems related to the equilibrium in coplanar cases. Thanks for watching and have a nice day.